Okay, so now I will demo the simulation of how the hacked IoT device affects the dashboard. Just a quick recap of our architecture. This is Raspberry Pi. It represents the car's internal computer network. And the page you are seeing right now is the screen of Raspberry Pi I access remotely. And the Mac, the computer I'm using right now, will represent the attacker. And the sensor.py, it represents a real sensor. It will send the actual speed in real time to this CAN bus channel, and the IC sync will according to the message in CAN bus to update its dashboard. And this script is hacked IoT device. It will open a port, wait for the HTTP request. Once it receives, it will using Python CAN to send a malicious CAN bus message into the same CAN bus channel to affect the dashboard. Now we're using this command to launch the vCAN0, and then we use a command to launch the sensor.py, so we can go back to monitor whether it received the CAN message. Yeah, okay, so this one is a message the sensor.py sent to hear the CAN bus. And then we can move on to open the dashboard. I set the speed to bouncing around 60 to simulate I'm driving right now. Okay, we can move on to stop the hacked IoT device, and then we can use in the attack message, attacked from Mac. Here, I open the Mac browser and using the attack message. Here can set what speed we want to attack, like say 220. Start, you can see. And I set the attack will continue at second. After at second, it will go back to normal. Okay, let's try 30. Okay, see. Let's talk about how to prevent this. So right now, the architecture is like this. We add the Guardian. The Guardian will take the vCAN0 as an input and output to the vCAN1. Inside the Guardian, we do the two security check. First is HMAC signature. So the principle is the secret key is shared only between the sensor and the Guardian. The sensor will compute an HMAC signature over the message, and the Guardian will recompute the HMAC and check if it match. So attacker cannot generate a valid HMAC without the secret key. But what if the attacker already got our old valid CAN message, so they can keep resend it? To prevent this, here comes the second security check, counter. The principle is each CAN message includes the increasing counter, so that the Guardian check the last accepted counter, old and repeat counter are rejected. So right now, the attacker cannot take an old valid message and resend it. Now let me show you how this works. We launch the sensor, and then we can monitor vCAN0. Okay, this is a message inside the vCAN0, and the last 4 bytes are HMAC. This byte is the counter. You can see they are counting, and this byte is the actual speed. We monitor the vCAN1 right now. Okay, you can see nothing inside the vCAN1 since our Guardian is not launched. Okay, right now, let's launch our Guardian. Go back to see the vCAN1. The vCAN1 is receiving the message from the Guardian, and also the IC sync show the speed because it received the message from the vCAN1. Okay, and now we launch the hacked IoT device. We go back to the Guardian terminal, and right now we can do the same attack again and see what happened now. Let's do 20. Let's go. Okay, you can see the red word is the invalid message. The dashboard doesn't affect.